In section 7.5, we look at strategy for integration. And integration is hard because all the problems start off with the integration of something, and usually dx or dm or a variable. So our methods are use sub that we learned in 5.5, integration by parts that we learned in 7.1, trig identities, section 7.2, that's where you do like you did in verify back in trigonometry. Triangles or trig substitution in 7.3, and partial fractions in 7.4. So the problem is when you get out of chapter 7, they don't all, when you're looking at integration in general, they don't always separate out. So you have to practice doing them together. Sometimes you need more than one method. So let's look at this real quick. This is a table of integration formulas, and these are the integrations that you should know. Well, I will tell you that on your tests, you're gonna need some of them more, but these are the most common ones. You should know the power rule and e to the x and sine x and secant squared and secant x tangent. Some people this one's the integration of secant x is one that you would use regularly. I don't memorize tangent x because I develop it every time I use it. This one we know that we've used a lot. And then natural log of x, the power rule, cosine. These ones over here, the inverse trig functions, I don't use them as much. If they show up on your quiz or your test, I'll happily give those to you. So the circled ones are the ones that you should be able to use. I think number 11 is one that I won't make you memorize. So as far as it goes for me, those are the ones that you should know as you walk into a test. The ones that are circled minus number 11. So in section 7.5, we learned some tips. The first tip is simplify if possible. If you can distribute, if you can split the fraction, if you can FOIL, simplify if possible. So try and see if algebra will make your integration easier. Step number 2 is always look for use sub. Use sub is your best tool, followed closely by integration by parts. So look carefully and try use sub before you try anything else. So our third technique is to classify by form. So we can try trig functions or identities. Look and see if it looks like that's going to be happening. Partial fractions. When you see a fraction or a rational expression, see if partial fractions may work, which remember that includes dividing. Integration by parts. So if you have a product of two items, integration by parts. And then if you have radicals, you might be able to use your triangles or your use sub. So that's your third technique. So then our fourth technique is to try again. So if you're not getting anywhere, try use sub. Look at integration by parts. Look at the algebra like you did in trigonometry. Maybe you can split a fraction, or maybe you can simplify in some way. Relate to a previous problem. We've seen the integration of secant to the third a few times, so that might be helpful. But remember, you may need several methods. You may need integration by parts along with trig identities. So just practice. That's all you can do is start them and practice and work through them. So let's look at a couple. So this one says the integration of tangent to the third x, cosine to the third x. Now if you remember, tangent is sine over cosine. So that's an interesting way to start, but that's just going to give us sine to the third over cosine to the sixth. That's probably the way I'd go. There's a couple ways to start. Let's do that. Let's say that this would be sine to the third x over cosine to the third x times 1 over cosine to the third x dx. This gives us sine to the third x over cosine to the sixth x dx. Everything in terms of sine and cosine is easier in my opinion. So we know that u sub will work if we can change it to one sign in the top. So let's call this sine squared x cosine to the 6th x and put the other sine x out here. Just because I know if I let u be cosine, then du has to be sine. Now sine squared can be rewritten as 1 minus cosine squared x over cosine to the 6th times sine x dx. So now we can split the numerator into 2. I would split it, but it may be easier to do u sub here first. Yeah, let's go ahead and do that. Let's let u equal cosine x. Then du is negative sine x. So dx is negative 1 over sine u, sine x du. So now we have the integration of 1 minus u squared over u to the 6th. And here we have negative 1 over, we still have our sine x out here. Sine x. And then our dx becomes negative 1 over sine x du. So these cancel, and we have negative 1 plus u squared over u to the 6th du. So you can say u to the negative 6th, negative 1 plus u squared du. So this gives us negative u to the negative 6th plus u to the negative 4th du. So we have, when we add 1, we get negative 5. So it becomes positive 1/5 u to the minus 5 minus 1/3 u to the minus 3 plus c. So we have negative 1 over 5 cosine to the 5th x minus 1 over 3 cosine to the 3rd x plus c. That's actually a positive 1/5. So look at that same problem, tangent to the 3rd x over cosine to the 3rd x dx. So we could start this problem as the integration of tangent to the 3rd x secant to the 3rd x dx and use the trig identities like in section 7.2. So I know that the derivative of secant is secant tangent. So I'm going to do tangent squared x secant squared x tangent x secant x dx. So I want to replace that tangent with secant squared x minus 1 because I know that secant squared x equals 1 plus tangent squared. So tangent squared equals secant squared minus 1. And we continue secant squared x, secant x tangent x dx. So let's let u equal secant x. Then du is tangent x, secant x dx. So dx is 1 over tangent x, secant x du. So we have the integration of u squared minus 1 times u squared times tangent x secant x dx times 1 over tangent x secant x du. And these cancel. So we have u to the 4th minus u squared du. So when we integrate that, we have 1/5 u to the 5th minus 1/3 u to the 3rd plus c. So we have 1/5, and u is secant to the 5th x minus 1/3 secant to the 3rd x plus c. Now make a note of the fact that secant is the same as 1 over tangent. So it's the same answer we got back here. It just looks a little differently because this could be 1/5 secant to the 5th x minus 1/3 secant to the 3rd x plus c. So sometimes there's more than one way to do the problem. You just need to be diligent and continue. Let's look at another one. It says the integration of e to the square root of x dx. Well, you know you can't integrate e to the anything except x. This one's an interesting problem. Let's start with u sub, but I know where this is going. I can see the future. So let's let m equal the square root of x, which is x to the 1/2 power. Then dm equals 1/2 x to the minus 1/2 dx, which is 1 over 2 square root of x dx. So then dx equals 2 square root of x times dm. So this means we have the integration of e to the m times 2 square root of x dm. Now notice up here the m is the square root of x, so this is m right there. Because you can't integrate with a mix and match of variables. You can only do single variable. So we have the square root of e to the m times 2m dm. Well, we normally see it 2m e to the m dm. Do you see integration by parts at this time? So pause the video, work through integration by parts, and then come back. So let's let u be 2m, and that means that dv will be e to the m dm. So when we integrate e to the m, we get e to the m, and we take the derivative of 2m, we get 2 dm. So then this up here becomes the integration of u dv, back to the original problem, equals uv, so 2m u times v e to the m minus the integration of v e to the m du 2 dm. Well, that's not too bad. So we have 2m e to the m minus the integration of that is 2 e to the m plus c. Now you got to remember we didn't start with m. M is the square root of x. So we have 2 square root of x e to the square root of x minus 2 e to the square root of x plus c. So this one took two techniques. Over here we have u sub, and then it became integration by parts. So sometimes you have to do more than one method. Look at this problem. It says the integration of dx over x square root of ln of x. Now, whenever you see ln of x, you should think integration by parts. But the problem is it's inside the square root. So just in case we're doing integration by parts, you should start with u sub, but let's call it m. Let m equal ln of x, and then dm is 1 over x dx. So dx equals x dm. So then you have the integration of the bottom, you still have x. And then the square root of m. And on top, we're going to put dx, which is x dm. So these cancel. I like my dm at the back. So let's say m to the negative 1/2 dm. When you integrate m to the negative 1/2, you add 1 to be m to the 3/2, and here I have 2/3 plus c. So we have 2/3 natural log of x to the 3/2 plus c. So that one didn't require integration by parts because u sub worked. Look at this problem. It says the integration of, it's a big square root, 1 minus x, 1 plus x dx. We want to rationalize here. That's what we tend to think, but think about if you multiply by the top, then you'll end up with something similar to the triangles problems. So if we multiply by the square root of 1 minus x, we get the integration of 1 minus x over the square root of 1 minus x squared dx. Pause for a minute and think about that. So then we have triangles, and this is a leg, so my hypotenuse is 1. I'm going to put x over here and the square root of 1 minus x over here. So we're going to let sine of theta equal x, which is x over 1. So x is sine theta. I tend to want to write it nicely. So dx is cosine theta d theta. So we can come back to here and we can say the integration of 1 minus sine theta and on the bottom we have the square root of 1 minus sine squared theta, and dx is cosine theta d theta. So we have 1 minus sine theta, and on the bottom we have the square root of cosine squared theta. This is not a bad problem. Cosine theta d theta. So we have 1 minus sine theta, and then we have cosine theta here and cosine theta here, so they're going to cancel. So we have the integration of 1 minus sine theta d theta. So the integration of 1 is just theta, minus the integration of sine is negative cosine theta, plus c. So if we read the triangle, let's go back here. Sine theta equals x. So theta equals inverse sine of x. So we have inverse sine of x. Plus, if we read the triangle, the cosine is the square root of 1 minus x squared plus c. I left that squared off earlier. Hopefully you caught that. So it's not, the section's not difficult overly. You just have to pay attention and use more than one method often. So pay attention to the techniques that you've used and think about them, and you can do it. Thank you.